Assalamualaikum and greetings to the audience. My name is NABILAH BINTI ADIMIN, and today I will be presenting my final year project entitled Enhancing Urban Green Space Using Geospatial Techniques and Analytic Hierarchy Process in Alustar. So this project is focuses on the use of geospatial technology and decision-making tools to improve the green space planning in rapidly urbanizing areas. So to start, let me explain to you what is the urban green space. So basically, urban green spaces are critical for sustainable development because they help in reducing air pollution, lowering urban temperatures, supporting biodiversity, and improving community well-being. However, in cities like Alor, rapid urban development is threatening these green spaces. So my study aims is to identify the best areas for green space enhancement by integrating GIS and AHP-based analysis. So this study has three main objectives. So the first objective is to identify priority areas for green space enhancement in urban areas. The second one is to classify urban areas based on their potential for green space using geospatial techniques. And the last one is to produce a suitability map using GIS and the analytic hierarchy process, or known as AHP. So these objectives are guided by the three research questions such as what are the potential sites for urban green space development in Alusata? And the second one is how can geospatial approaches be used to classify urban areas in terms of the potential for green space development? And the last one is how can GIS and AHP be combined to create a suitable map for green space planning in Alustar? So for the methodology, this study integrates two powerful tools such as geospatial analysis and the analytic hierarchy process AHP. So for the first step is I use Sentinel-2 satellite imagery from 2023 to generate NDVI maps that reflects vegetation density. Next, I perform supervised classification to produce land use land cover LULC maps. Then I identified relevant criteria for green space suitability such as NDVI, slope, elevation, distance from roads and rivers, and soil type. So these layers were standardized, weighted using AHP in Excel, and combined using weighted overlay analysis in QGIS or ArcGIS. So the final output is a suitability maps for green space development in Alosata. So as you can see in the poster, there are two results, which is NDVI and LULC map. So let's start with the NDVI analysis. So NDVI is the normalized difference vegetation index. It is a widely used in a remote sensing indicator that helps measure the density and health of vegetation using reflectance from red and near infrared bands in satellite imagery. So in this study, NDVI values were calculated using Sentinel-2 satellite imagery for the Alustar area, with the values ranging from approximately negative 0.13 to 0.56. So these values are consistent with the expected spectrum for the urban landscape where vegetation and built-up features coexist. So areas with the higher NDVI values, which is closer to 0.5, indicates healthy dense vegetation. These regions are largely concentrated in the eastern, northeastern, and northern parts of Alusata, which are dominated by agricultural land and open green spaces. This includes paddy field, plantations, and undeveloped land. On the other hand, the lower NDVI values close to zero or negative are observed in the central and southern zones areas corresponding to built-up regions such as the city center, major roads, residential neighborhoods, and commercial zones. These low NDVI zones represent vegetation stress, limited greenery, or entirely built-up land. So the spatial patterns of NDVI clearly reflects the ongoing urban development pressure in Alustar. The central region, which is the urban core, shows fragmented and sparse green coverage, while the peripheral areas remain vegetation-rich. So this NDVI analysis is critical for urban planning, as it highlights areas where green space is lacking or undertreated, which is helping the authorities prioritize them for regreening efforts or green infrastructure development. So next, let us move to LVLC analysis. So the land use and land cover, or known as LULC map, was produced using supervised classifications on the same Sentinel-2 imagery. This approach allows us to categorize land into distinct classes based on their spectral reflectance. So the classification used in this study is identified as three major land cover types, which is built-up areas, vegetation or agricultural land, and water bodies. So from the classification result, it is evident that agriculture land and vegetation land dominate much of Alustar's spatial footprint, particularly in the central and northern sectors. So these zones are critical for food production and ecological balances. Built-up areas represented in red are highly concentrated along the city center, especially around the Kedah River and major road networks. These areas represent intense urbanization and infrastructure development. For the water bodies, though less prominent in area, it is play a crucial role in the environmental sustainability of the region. They are located along the river system and scattered irrigations channels across the landscape. So, from the LULC map supervised classification, we can see it is the visible trend of urban expansion into agriculture zone. The enlargement of built-up areas on Green Island is particularly noticeable in the eastern and northeastern edges of the city, suggesting active land conversion. Moreover, areas previously rich in vegetation are now becoming fragmented or discontinuous, which could lead to environmental degradation if not managed properly. So, in conclusion, this study aimed to assess and enhance urban green space in Aluseta using geospatial analysis techniques. So, the main outcome of this study is a clearer spatial understanding of the current distribution of green spaces in Aluseta. This finding serves as a crucial baseline for monitoring changes in vegetation over time and for identifying zones that lack adequate greenery. By visually and quantitatively highlighting areas with limited vegetation, this research supports data-driven planning for future urban green space development. That's all from me. Thank you.